Okay, so what we're doing is we are completing the square, and when we complete the square, it enables us to be able to factorize and calculate the value of x of a trinomial that won't give us a nice number there necessarily. Okay, we can now factorize any trinomial that is possible to factorize. So what I'm going to start with is I write the x squared plus 4x. Then I take half of 4 squared, which is 4. I add it and I subtract it from the value of c equal to 0. Do you all agree with that? Okay. Now these three terms, they're a perfect square. I rewrite them as x plus 2, close the bracket, square. And then these two I take to the other side of the equal to sign. And the answer is equal to 10. Then I take the square root both sides. And I end up with x plus 2 equal to plus and minus the root of 10. And I asked you to keep these answers in the simplest surd form. So all you're going to do in an exam, if you get that, is you write plus minus root 10 minus 2. If you wanted them as a decimal, then that's going to be what you type in your calculator. You just take your calculator, you say root 10 minus 2 equal to, and convert. Then you've got the one answer. Then you just go back on your calculator. On the outside of the root, you put the negative, convert it. It's negative 5,16. Who got it right? Good. Okay. It's not hard, no? So that's the basics of completing the square. All that complicates it now is when they can put in, when we're stuck with a few fractions. That can make it a bit more difficult. So I'm taking b, x squared plus x minus 1 equal to 0. Do you see, if we didn't have this method, we would be stuck at this stage. We can't factorize this trinomial because there aren't factors of 1 that will give me 1 when I subtract them from each other. Okay, doesn't work. So I'm going to complete the square. Now don't let fractions confuse you. If there was a 10, what would you have done? You'd have said 5 squared, 25, added and subtracted. Don't let the fractions scare you. What is, if you're struggling, just take your calculator, né? You take the value of b. What's the value of b then? 1. You say 1, divide by 2, square, equal to, it's a quarter. So you don't have to do that calculation in your head if it's a fraction and you're struggling with it. So I add a quarter minus 1 and I subtract a quarter equal to 0. Did I do anything different? No, it's all the same. These three, they make out a perfect square. So it's going to be x plus the square root of a fraction is easy. You take the square root of the top one and you take the square root of the bottom one. So it's gone, and remember, you just listen to what I'm saying now. You just squared it. Do you know that? So therefore, it's going to be a perfect square. That will give you a rational number. Because you squared it, so you're going to square root it back to half of whatever is there. So it's going to be a half, because square root of 1 is 1, square root of 4 is 2. Put the square root there, and then minus 1 minus a quarter is minus 1 and a quarter. So I take it over, it's 1 and a quarter. Now you can use it as 1 and a quarter, or you can use it as 1 times 4 is 4 plus 1 is 5 over 4. It doesn't matter which one you choose. And then you take the square root on both sides. I've got x plus a half equal to plus minus the square root of 5 over 4. I don't like mixed fractions personally, so I just used the improper. And this one you also had to leave in simplest surd form, so you can write square root plus minus the square root of 5 over 4 minus a half. Now I just want to quickly show you, and I would suggest you doing that. if you're leaving it in simplest surd form, just type that surd form in your calculator. Because do you see when you look at that square root, 5 cannot be square rooted, but 4 can, because it's a perfect square. That means there is a simpler form. But don't let that stress you out. Just type it on your calculator. Oops. Need to get out of that thing. Minus a half. And I press equal to, and then it gives it to you in the simplest form. You can just copy it. So it's minus 1, and then you know most it's plus minus the square root, né? Over 2. So I just put in that plus minus because I know the square root must be added and subtracted. But I didn't do that. The calculator did it for me. Okay, you see now once again it's a uneven number, which means I expect getting a fraction when I divide by 2. But don't let it stress you out. You take your calculator, you say 5 divided by 2, get the answer, square root it. It's 25 over 4. Nothing to think about. Plus 25 over 4. Do you see perfect square at the top, perfect square at the bottom? Because I squared it. And then I also subtracted 25 over 4. These three, they make out a perfect square. So it's this one square root. And now I just want you to know that here we have a negative, where with the others we've had positives all the time. You're going to use that one sign. Okay. So in your bracket you put the negative, and then it's 5 over 2. Close the bracket, square. You can do that calculation on your calculator. 2 minus 25 over 4. It gives me an answer of negative 17 over 4. Can I somewhere take it over so long? So it can become 17 over 4. Square root both sides. So I've got x minus 5 over 2 equal to the square root of 17 over 4. I just want to show you, if you were to write this correctly without using the calculator, it would be the square root of 17, and then at the bottom would be 2. So 4 just got out of the root, then you have to take the square root. Do you understand what I did there? That's how your calculator changes it from that to that. Just takes the 4 out, but if you get out, the calculation needs to be made. Okay, and we can do this, we can take out one of them if they are being multiplied or divided inside of the bracket, not addition and subtraction. Okay, now the minus 2 has to go over. It's a plus minus here, or a plus minus there. So x is equal to plus minus square root 17 over 2 plus 5 over 2. And your calculator gives it to you like this. Plus minus square root 17 plus 5 over 2. Because the denominators are the same, then you can write it as one fraction. Just add the numerators. Do you remember in grade 8, I taught you to add your fractions like this? I said when you see the denominators are the same, write it as one denominator. Then you just do the calculations at the top. That was why I taught it to you like that, way back then. Because we know what we are working towards. Okay, everyone done? Right, let's go to task 5. Do you see the difference in the sum at this one? Okay, I want to show all of you how to change this, because this has happened to all of us. Do you agree with me? Your calculator, you press the buttons accidentally inside of your pencil case or whatever, and then you get this and you can't work with it. So before you start with a test or an exam, you need to get into the habit of doing this. You press shift, no? Do you see at the top of the 9, there's a C-L-R, clear. You say clear. Then there are setup, memory, all. You say 3, reset all. And then they say if you want to say yes, you press equal to. If you want to cancel, you press AC. So I want to say yes, reset all, press all clear button. Okay. So shift 9, and then you accept it until it's clear. Do you see the difference between this sum and the ones that we did? I've now got a coefficient. Now once again, normally what we would do here is we just divide with 2, and that is still the correct way to do it, but we're just using an easy one, just to understand it. Okay, then we're going to go to those. For example, I can't take out a 3 in common. You see that? Okay. So I know here you could have just taken out a 2 in common and then it's normal. You go on normally. But I want to show it to you where we are not working with fractions right from the beginning. Okay. So the steps are the following. Take, and this is the weird thing. This is what we're not used to. Take the a value out of the 2x terms. So normally when we take out something in common, we need to take it out of all of them. Do you agree with that? But now when we take it out, we only take it out of those two. Whether that's a 4 that can divide with 2 or not. If that was 5, you take that 2 out. You know how to take a number out. You divide with it. Okay. You'll see with the examples what happens when they can't divide. So you take it out of those 2 terms and you put it in front. Okay. Then you've got x squared plus 2x. Do you know where the 2x came from? It's 4x divided by 2. This is now your b value. Okay. This is the one that you're going to divide by 2. 2 divided by 2 is 1. 1 squared is 1. That you are going to add. And now I have a problem. Don't copy this, I want to show you. Remember, do you remember why I add and subtracted? No? Do you remember? Because otherwise I changed the equation. I must add and subtract the same number. Now look at this. Don't copy. What I'm going to do now is wrong. Look first. If I add it here and I subtract it here, I just quickly want to multiply this bracket out. It's going to be 2x squared plus 4x plus 2 minus 1 minus 6. Do you see what's happening now? I've added 2, but I've only subtracted 1. Do you understand the problem? Grade 11s, everyone. So I'm going to give you the solution now, but you need to understand why it's a problem. Why you need the solution, because then the solution will make sense. Now, do you remember, I just asked you, if I want to take a 2 out of the brackets, like I did here, what did I do to take it out? I divided. So if I want that negative, that 1 that I'm going to subtract as well, I'm actually doing it there. For that 4x to be inside of my bracket, I divide it by 2. What am I going to do if I want that negative 1 outside of the bracket? Times with 2. So I take that value and I multiply it with whatever the coefficient is. If I had taken out a negative, I would multiply that thing with a negative to go out. If I had taken out a 10, I would say, right, 1 times 10, then I know what has to be on the outside. Does that make sense? Okay. So the thing I'm subtracting on the outside is once again the same as I'm adding, but multiplied with the coefficient. And therefore it's minus 2. So we are just doing it here as well. If you had done the investigation, you have done it by yourself. You wouldn't have had this explanation. So there are just more steps. So we say fill the open spaces with the following. The first, the value needed to make the trinomial inside the bracket a perfect square. The second, the same value as the first multiplied by the coefficient. In this case, 2. So not just always multiply by 2 to get out, multiplied by the coefficient. Do you understand? Okay, good job. Now they say take the simplified constant outside of the bracket to the right hand side. So what's the simplified constant now? Negative 8. I'm going to take it to the other side. It's going to be positive 8. On this side I've still got, you don't have to do all these steps as I say. We're doing it step by step according to the investigation. The next step is factorize the perfect square in the bracket to the form a plus b squared. You can do that. That's what we've been doing all the time. So this 2 stays on the outside. Here I've got this one square root, this one sine, this one square root. Close it. Put the square equal to 8. Now we're just going to calculate it in the same way. But before we can take the square root here, we just need to get the bracket alone. Just like we got the root alone with the previous work. You remember that? Okay? So I divide both sides with 2. Then this side is gone. I've got x plus 1 equal to 4. I take the square root of both sides. So I've got x plus 1 equal to plus minus 2. And then my two answers will be x equal to 2 minus 1 and x equal to minus 2 minus 1. And my answers will be 1 and x equal to negative 3. Grade 11, so 2 things happened now that you haven't seen before. The first thing is that you take a number out of only 2 terms, not the whole thing. If you only take it out of 2 terms, then only those 2 terms can go into your bracket. The second thing that we saw here that is a bit funny is that number that I'm adding, that I subtract on the outside, will be the same number, but it has to multiply with the coefficient. Those are the 2 things. It's the only 2 things that are different. But what's going to complicate it now is that we will have a lot of fractions. Okay? That's what complicates it. But most of the time, whenever you're going to use it, you're not going to get those fractions. And you can relax. This is an important, very, 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 very important part of grade 11 maths that you have to understand and that we're going to use at functions, but we are not going to use this way to factorize. There's an easier plan coming up. Okay. Or not a plan, it's the same thing, it's just a bit simplified. But you must be able to complete the square. Okay. Right. So, 5.1. Solve the following by completing the squares. Always start by getting the equations in standard form. Standard form. Do you know what standard form is? Ax squared plus bx plus c. That's not in standard form, ne? So this one in standard form will be 3x squared minus 24x plus 11. The signs don't change because they didn't move around over the equal to sign. I'm just shuffling them to be correct. Now I can take out a 3, but I only take it out of the first two terms, the x terms. That constant is just hanging around. He's not doing much, ne? He's only going to be square rooted with whatever is happening later. So I take out the 3, then I'm left with x squared minus 8x. Can I already add that special number? What is it going to be? 16. Half of 8 is 16. Is 4. 4 squared is 16. So I know I add it there. And then I close my bracket. That's my perfect square. So on the outside, it doesn't matter in which order you write this. I've still got that c value plus 11. But do you see now I have that extra value there that I haven't subtracted as well? Who can tell me what the number is that I'm going to have to subtract? 48. How did we get to 48? 16 times 3. So this one times that one will give me the value of minus 48 on the outside. Equals to 0. Now the two things that are different, we've already done. Now it's just the same as the ones we did for today. I leave the 3 on the outside. This is a perfect square. It's x, that one's sine, that one's square root. Close it. And then I've got 11 minus 48. That gives me negative 37. Do you agree? I'm going to take it over as well. So I've got it equal to positive 37. Now before I can take the square root on both sides, I must get the bracket alone. So I'm just going to divide with 3. So I have x minus 4 squared equal to 37 over 3. Now I can take the square root. Is 37 or 3 a perfect square? No, so I can't let them get out. They must stay inside. And now I just take the 4 over. So I've got plus minus the square root of 37 over 3 plus 4. And if you wanted to give it as a decimal number, do you know how to do that? You just type it in your calculator. I say the square root of 37 over 3 on the outside of the bracket plus 4. Convert it. My answer is 7,5, or I go back on my calculator, put a negative in the front, and my other answer is 0. equal to 0, comma, it's 4, 8, so it's 0, comma 5. Do you understand? Are you going to try 5.3 as well by yourself? Okay, but I just want to say, remember, get it in standard form, but I don't want you to divide the 3 out. I know we can divide the 3 out. Don't divide the 3 out so that we can just practice it with a better number. Do you understand? I'm going to do this one with you. Then you can try the last one, okay? You see that's not standard form, ne? I want it to be 3x squared, but that means it's on the other side, ne? Or I'm multiplying with negative. And then minus 6x, and then minus 12, equal to 0. Do you understand the signs? I basically took them to the right hand side. That's why negative 3x squared became positive, 6x became negative, and negative 12 stayed what it was. Whether I say 0 equal to this or this equal to 0, it's the same thing, ne? So firstly, I'm going to take out the 3. What's the magic number? 1. 2 divided by 2 is 1. 1 squared is 1. What's that one going to be if it goes out? Negative 3. So now I've got a 3 here. This one square root, this one sine, this one square root, close the bracket. This is minus 15. I'm going to take it over. It becomes positive 15. Now before I can take the square root, I need the bracket alone. So I divide with 3 on both sides. 15 divided by 3 is 5. I take the square root, so x minus 1 is equal to plus minus the square root of 5. If you can't take the square root, it stays in a third form. You don't have to do anything about it. And then x is going to be equal to plus minus the square root of 5 plus 1. And if you want to give it as a decimal answer, you type in your calculator square root 5, get out of the root, plus 1. The one answer will be 3,2. And then you go back on your calculator, put a negative in front of the bracket, and then the other answer is negative 1,2. Are you quickly going to try 5.3? Okay, get it in standard form first, no? Did you see this one worked out very nicely? Good. Okay. Alright, are we going to practice it? Exercise 5, same one we are busy with. I want you to do D, E, F and G. D, E, F and G. And then number 3. D, E, F and G on page 29. So you do D, E, F and G of that question 1. And then you do number 3. With those pages, you paste it in. If you've forgotten how to complete the square, you can go and look at it again. You're going to need it. Tomorrow we're going to do another investigation that counted marks in previous years for the next part of how we're going to actually use this completing the square.